In this video, we will explain a study about gas flow meter in the industry, and we have chosen to use ultrasonic type of gas flow meter in this video. The study of gas flow meter experiments. There are two research papers that we will use to explain all the information gathered in this slide and also video. The first one is research paper entitled Review on Transit Time Ultrasonic Flow Meter, written by Rajita G in 2016 in the report named Second International Conference on Control Instrumentation, Energy and Communications. The second research paper is written by Lunde P in year 2000s. The paper entitled as GERG Project on Ultrasonic Gas Flow Meter. GERG here referred as European Gas Research Group. Introduction for ultrasonic gas flow meter. Previously, in the field of gas measurement, most domestic gas meter used is orifice plate gas flow meter. There are four types of natural gas meter that are often used for gas measurements. The first one is mass flow, for example, thermal mass flow meter. Secondly, velocity. Turbine, vortex, and ultrasonic gas flow meter is the example for velocity gas meter. Third one is differential pressure meter, such as orifice plates. And lastly, positive displacement gas flow meter. With the development of electronic information and the internet technology, ultrasonic flow meter has become a new type of intelligent instruments. However, ultrasonic flow meter achieve remote data transmissions. In a combination with internet technology, it able to solve the problem in field regarding meter readings. The ultrasonic flow meter able to measure and calculate the volumetric flow by summing up the weight fluid velocity across the diameter. The benefit of using ultrasonic gas flow meter is it responds quickly to any change in flow. Secondly, it increases time between calibrations, and also it has a modular design. There are two types of ultrasonic flow meter that can use as an alternative for flow measurement in the pipeline: the transit time ultrasonic flow meter and Doppler ultrasonic flow meter. However, transit time ultrasonic flow meter is the most used in the industry. Transit time flow meter can easily deal with nanosecond range time interval to obtain high accuracy data. Transit time flow meter do not create any flow restriction in the pipeline. They are used in many cases in which the flow restriction is unavailable. And for this type of flow meter, they offer a wide range of pipe size from very small to very large. For an example, from 10 mm to 9 m in diameter. It is also easy to install in retrofit applications. Retrofit refers as an addition of new technology or features to an conventional system. Normally, the objective of this application is to improve the power plant efficiency and also to increase the output or other purposes. The components from this type of flow meter are easy to remove during maintenance.
For theoretical explanation, ultrasonic meters are velocity meters by nature where they measure the velocity of the gas within the meter body. Ultrasonic meters derive the gas flow rate by measuring electronically the transit time of high-frequency sound pulses. Transit times are measured for sound pulses propagating across the pipe at an angle with respect to the pipe axis, downstream with the pipe gas flow, and the upstream against the gas flow. For each acoustic path, the difference between the upstream and downstream propagating transit times is proportional to average gas flow velocity along the acoustic path. Multiple acoustic paths are used to sample the flow velocity of the profile in the pipe at a set of discrete chords to improve the metering accuracy. Numeral integration techniques are then used to calculate the average axial gas flow velocity and the volumetric flow rate through the meter. Different types of geometrical path configurations and numerical integration methods are employed by the various meter manufacturers. In some instruments, the paths are configured with parallel cords. The measured upstream and downstream transit times contain possible time delays due to the electronics, cables, transducers, and diffraction effects, and possible cavities in front of the transducer. Transit time is the most significant effect of the meter's operation, and all other inputs to determine gas velocity and speed of sound are essentially fixed geometry constants.
Now I will explain about the current application of ultrasonic gas flow meter in the industry. In recent years, ultrasonic gas flow meter technology has been increasingly taken into the use for physical metering of natural gas and is gradually considered as a more realistic and competitive alternative compared to a conventional method by using turbine and also orifice plate flow meter. In natural gas processing system, you can see the usage of ultrasonic gas flow meter in gas distribution metering, flaring system, time blanketing, and also stack gas monitoring. For the first one, gas distribution metering, many chemical processes require a large varying volumes of specific gas such as oxygen, nitrogen, and argons. However, hydrogen gas may be required as well as a catalyst, and other specific gas will be also used in the process. The accurate measurement of this gas is important for process control, gas inventory control, and also cost management. Secondly, for the flaring system, in petrochemical production, especially in refining and storage sections, flare gas systems are used to burn off and dispose waste or excess gas as a safety measure. Hence, the most accurate, responsive, and reliable measurement of flare gas is essential in order to assure proper operations of flare gas systems. This is to protect the people, workers, equipment from any hazardous combustible gases, and in order to maintain a safe working environment and also to protect the environment from any contamination. The third application of ultrasonic gas flow meter in the natural gas processing system is time blanketing. Nitrogen gas is used in blanketing system in the chemical and petroleum refining industries. This is in order to reduce any hazard associated with flammable liquids. Blanketing or padding is a system of applying inert nitrogen gas to the vapor space in a tank or a vessel to minimize the possibility of explosions or fire by reducing the oxygen content and also the concentration of flammable or explosive vapor. Lastly, the stack gas monitoring system. In this process is used to measure the output of waste gas in a plant and a vessel equipped with scrubber system. This type of vessel normally require a multiple type of flow meter. This stack gas system is very important to ensure the gas emits from the process meet the requirement or environmental standards.
Okay. Next, we proceed with the advantages of ultrasonic flow meter. So first, the device is high accuracy, which can be calibrated into less than 0.1%. So next is naturally directional, which means it measure flows in both measure volumes in both direction with comparable performance. Next is tolerant with wet gas, so it's important for production application. And next, it has low maintenance, which means it has no moving parts, so means it's low maintenance. So next is integral for diagnostics. Data for determining a meter helps is readily available. So possibilities of self diagnostics. So next, it has potential of remote operation. So next, it has potential for reduced dependency on flow calibration. So next, it has a non-intrusive measurement, so means no obstruction of flow. And next, the USM has no pressure loss. It also have large turn-down ratio, which is around 40 to 1 or larger, reducing the need for multiplicity of meter to cover wide flow of range, and that's its possibilities for fast time response. It also has short upstream and downstream requirement with respect to bands. And lastly, it's provide with additional information about flow and gas properties such as velocity profiles, sound velocity profiles, and which might be used in for density and calorific value determination. Okay, so and we proceed with the disadvantages of USM. So USM is a relatively complex and complicated metering technology. It is new technology which will benefit from further maturing and extended experience with the use of USM. It also have uncertain sensitivities to installation conditions. It also has sensitivity to ultrasonic noise, such as for installation close to pressure regulation valve, and also it lacks of industrial standards.
I'm NORDIN, and I will be presenting about the potential improvement that can be done to the ultrasonic gas flow meter based on the case study that have been mentioned by my roommate. So, the first improvement that we can done is determining velocity distribution. As you can see, the figure is the outcome of a fluent numerical simulation relying on the RNG turbulence model. To allow an inside perspective, parts of the pipes are cut out. The velocity profile are seen as envelopes over the arrowheads of the local velocity vector at three distinct cross-sections, visualizing the phase of profile deformation induced by this double bending out of the plane. Next, by using the flow condition that can be analytically defined, Calibra, a computational software for predicting the measurement errors of ultrasonic meter. The calibration factor will derive analytically for this condition contrast with the numerical outcome. For a machine mesh of 41 times 41 node points in a pipe cross section, the precision of the system was higher than 0.3%. Based on the method developed, the performance of different ultrasonic flow meter was tested for different source of flow disturbance, typically found in double bands out of plane. By generating artificial flow condition, it was possible to show that SWIRL only have a minor impact on meter accuracy. Profile deformation, on the other hand, have turned out to have a much greater influence on the performance of the ultrasonic flow meter. The sound pulse design, which is similar to the actual flow meter, was observed to be less susceptible to the disturbance test with the real velocity distribution taken into account. With respect to the tubing configuration, all meters are more or less adaptive to the angle of rotation of the meter. Again, the real flow meter in the performed contrast was less sensitive. Ultrasonic flow meter are less influenced by swirls than turbine flow meter, but are particularly susceptible to velocity profile deformation. In choosing best flow conditioner upstream of ultrasonic flow meter, this can be beneficial. Ultrasonic flow generation allows to refine ultrasonic flow meter with regard their flow disturbance. Within seconds, Calibra will produce performance making progress much cheaper than lab work. Other than that, we will review the transit time measurement, which is the time taken of propagating sound wave from one pipe to the another pipe. An uncertainty model have been developed for calculation of relative expanded uncertainty of USM, the propagation of input uncertainties of gas parameter, geometry parameter, transit time parameter, and the integration technique is accounted for, including correlated and uncorrelated contribution to the USM measurement uncertainty. This is based on the case study of what we have been researched about. Using the program, a simplified and limited uncertainty analysis has been carried out for a 12-inch 4-pass USM. Example of estimated input uncertainties have been used to examine and the relative expanded uncertainty of the meter. By simplified analysis is meant that a sufficient complete investigation regarding input value for all uncertainty term appeared to in the uncertainty model have not been made here. A better basis of estimating the realistic value for the input uncertainties is needed in order to estimate a realistic relative expanded uncertainty for the meter. The uncertainty model has been used and tested critically, preferably in combination within controlled experiments in order to investigate the capabilities of the model to describe the propagation of input uncertainties in a realistic and relevant way for the types of USM considered here. Such testing work may also turn out to be valuable as basis for obtaining realistic estimates for the important input uncertainties. This is the future prospect of ultrasonic gas flowmeter and overall gas flowmeter. As you can see, from 2018 until 2003, there is a slight increase of worldwide market for flowmeter in terms of millions of dollars, from 7 billion to 9,000 billion US dollar, as oil price began recovering in 2016. The worldwide flow market is now back on a healthy upward track, such as correlations and ultrasonic flowmeter, which are industry approved for custody transfer of both and gas and liquid, are projected to experience the fastest growth rate. A study from Flow Research Project, the worldwide flowmeter market will grow from 7 billion to almost 9 billion by 2033 as the oil and gas industry continues recovering. This include the flow measurement technologies as the technologies become advanced year by year. So that's all for me. Thank you.